Welcome everyone to the 7th video on how to use Fusion 360. This time we'll be looking at how you can create an assembly made up of different parts or components. As you can see here, this is the assembly of the rocket engine that was used for the EUROAVIA rocket. So if you go to our data panel, we can go to the EUROAVIA rocket assembly, and let's just take a quick look. If we look at the EUROAVIA rocket, we can see that it has about 12 of these engines, and each of this engine is an assembly on itself, so every engine is made up of, again, more parts. As you can see, these are all the parts for the rocket, so these make up the rocket, and as you can see here, we've got the engine assembly itself. So if we take a look at the engine assembly, we see that we have the actuators, the nozzle itself with the combustion chamber, then we have our preburner that will turn the turbine for the oxidizer and fuel turbo pumps, and then of course we've got the gimbal. So let's try to recreate this assembly. If you want to create an assembly, you can just open a new file. But first of all, you will need to save it. So in this case, I will save it under courses. So save, and I'll call it test engine assembly. Okay, let's save that. So first of all, you need to save it. If you don't save it, you can't import parts. So just to show it, now you can just drag the parts that you've created into your project. You can place them, rotate them, all you want. And you can do this for multiple parts, and then using joints, you can, as it says, you can join them together to create assemblies. In this case, let's just cancel it, let's go back, and let's go to our rocket example. First of all, we will use our swivel mount, so let's import this one. Let's hit OK. Now, it's very important that for your first part you want to ground it. So here, just right click it and then go to ground. Now you will see this pin showing on your component. This means that it's grounded. So if I now want to move it, like just by dragging it, it doesn't work. And to show you the difference, let's import another swivel. Okay, just like that. This one isn't grounded, as you can see. And now I can just take it and move it anywhere I want. But of course, for an assembly, especially if you want to move it, like if you have actuators and you want to see degrees of freedom it has, most of the time you will need a part that's grounded so that you won't move the whole assembly. Like if I wouldn't ground it and I just connect all the parts on here, and then I want to try to move the nozzle, then just everything would move with it, which is not what we want. It's not what we're going for. So let's just delete this part. And now let's insert the other parts that we need. So we need our cardan gimbal, just like that. What I mostly do is just first insert like most of the important components, such as the ball bearings, just like that, and you can just copy and paste them. Okay. And let's also include our locking pins. Just like that. Just like that. Okay, let's hit the OK button. And now if you want to create a joint, you can go to Assembler and then just hit Joint. So now it will ask you to select your first component, then select the second one, and then you can also select which type of motion you want to give it. So you have rigid, revolute, so everything that's turns around. Then you have a slider, cylindrical. Cylindrical allows you to rotate and slide at the same time. And you have a pin slot, which is quite similar to a cylindrical one. Then you have a planar one, so just like line up two planes, and then the two planes can rub over each other, but they can still move in, let's say, the X and Y direction. And then you've got a ball joint, so then it's like a socket. So if you have a ball socket and you've got a ball joint, you can just join them, and then it has quite a lot of freedom. As you will see, because we will be using it, this example makes use of the ball joint for the actuators. But in this case, let's just start with our bearings, which we will give a rigid joint. To our gimbal mount, just like that. And make sure that you select the right face. Like if I would select let's say this face, then it will line it up with the other face that you've selected. So it could be that you will have a certain intersection, which is not the thing that you're going for. You want them to line up perfectly, so select that side, select this side. As you can see, it's perfectly flat. Here as well, there's no intersection, just like we wanted. Okay, now we'll do the same, but this time we'll go for a revolute joint. Select our cardon, and then select our bearing. As you can see, you most of the time you get a preview of what the degree of freedom is that you have. So in this case, you can just rotate it. Okay, just like that. And now let's insert our pins. We can just use a rigid joint for this as well. If you want, you can try to join the other side with a revolute joint as well, but like in these cases where you're primarily just doing for the aesthetics and just looking how it would work, because in these classes we're just looking at how you can create conceptual designs, it doesn't really matter, but you can do it. But do note that sometimes adding 2 or more constraints in the same direction, it can sometimes give you funny results. But yeah, I will try to show it to you, that you can perfectly do it. But let's first add this pin. Okay, and let's now create the joint that we want. So we're going to select the root joint, select this, and now let's select our bearing. As you can see, it works. So now I've got 2 revolute joints working, and if you want to move the joint, you can just select this and do drive joints, and now you can just drive it. As you can see, the other joint is like, depending on which one you move, the other one becomes a slave. So then you potentially have a master and a slave, but it really depends which one you drive. What you can also do is just grab the piece just like that and just drag it along. This also works, but it's sometimes a bit more difficult to find your original position. So I'm just gonna go back just like that, and let's import our other parts, such as in this case it was modeled as one part the rocket engine injector. And it also helps if you can already pre-orient your part, just like that. So again, we will need some bearings. Select our ball bearing, insert it, bring it down, give it the right position, and let's do the same over here. And as you can see now, I wasn't very careful and I didn't align them with the holes that we have on our injector plate. But as you will see, this can be solved. In most cases, Fusion will figure it out what kind of joint you're trying to make or how you want them to line up, and if it's not the case, you always have a tool to switch the orientation. I hope that I can show it to you. So let's say we want this joint, of course, revolute, like that. Select our, yes. So in this case, it got on just right. But let's see, like here, if let's say it was joined like this, and you can just hit the flip button and it would change to the desired orientation that I want it to be. Let's hit OK. Let's do the same for the other bearing. And as you can see here, you have this intersection, so to solve it, just click this the flip button, and it's fixed. Now let's connect our injector using a rigid joint. Yes. Just like that. Hit OK. And now let's insert our pins. These can also be rigid joints, just like that. Insert this pin. Joint and insert our last pin. Just like that. Okay, and just to check it, if we should take this, look, as you can see, we can move it. Of course, now we've got an intersection, but you can clearly see that we can move it in some directions. Just pretty curious if I can move it in the other direction as well. Let's see. No, we want to edit this joint, drive the joint. And so as you can see, now we've got this situation where it's locked, so we cannot move the gimbal sideways, which is a problem. We don't want this. So somewhere a problem occurred that we don't want. So in order to fix it, take a look where it went wrong. Let's just undo it. So these joints are both revolute. Yes. Okay, if we align it like this, will it work? Let's try grabbing it. No, still seems like we cannot move it in that direction. Let's press drive joints. Okay, now this time it works. Okay, so cancel. And let's insert our pins. The joint. Merge it. Just like that. Okay, do it for the other one as well. And maybe as you have noticed, a nice feature in Fusion 360 is if you create this cylinder or a hole, you can create a visual thread in it. So you can create a 3D thread in it, which is really nice, especially if you're into 3D printing. This is very useful as you can 3D print large diameters of thread. So here you can just do it with a thread function. Really useful. I highly recommend you trying it out. Okay, so now we've got this. The next step would be to take our nozzle and combustion chamber assembly. Where is it? Here, I found it. Okay, let's bring it down. Now I'll just have to make sure that it's aligned correctly. So let's see. It should be rotated about 90 degrees. It's because you can just right click it, move, and now rotate it to the desired position. Let's select J for joint, our faces, right now. Joint, select this one, just like that. Okay. Next thing we will do is add our pre-burner. Here we have the pre-burner. Okay. And if I'm correct, it was supposed to be assembled like that. Yeah. So we'll make sure that this aligns with the bottom of this, that bracket. Again, hit joint, select the other side of the bracket. Okay, hit OK. And now let's take the top part, our turbo pumps. Orient them in the right direction. Okay, especially if you have quite complex parts with inlets and outlets, it can really save you a lot of time if you already pre-position them correctly as to how you want to connect the other parts to it. So now joint. And as you can see, it lines up perfectly with the tube for the, if I'm correct, this is for the fuel, so for the regenerative cooling. That's this part. Okay. Now just to be sure, let's just connect the end of this. As you can see, in this case, it results in a conflict. It really depends on the joint you're creating, but sometimes it can give this kind of conflict, and if you would press OK, yeah, you can see like the joint that's. But in this case, if you really want to add this constraint, you can just change it to, let's say, planar. And if I'm correct, this one should work. You can just select that, select the other surface. As you can see now, it has created a plane at which it connects, but yeah, due to its orientation, it shouldn't really move. So hit OK. Now these two are connected, just like that. The next step is to connect our oxidizer pipeline. Again, let's try to pre-position it so that it has the correct orientation. Okay. Oh, still have to change something. Yeah, like sometimes you can see these lines, and this is because you saved them and they were visible in your original part. Because as you can see, if I would go to the oxidizer pipeline and just select this. Oh, okay, that's useful. Yeah, but like in some cases, you can have it that certain features are visible, but you cannot change them. So then you need to go back to your original part, change them in your original part, and then it's fixed. But yeah, for sketches, I almost forgot. Yeah, for sketches, you can just hide them in your assembly, which is really useful. But sometimes you will see like your model is not up to date and you have to update it. So then you just go back, you double click on your model, make the adjustments, and it will adjust in real time, or it will show like this triangle with an exclamation mark that will indicate like, hey, you've got a model, a part or a component that is out of date. And you can just click it and it will update. Okay, so again, let's hit the join button. Select our first part. If I'm correct, let's now just go for a rigid one. Or maybe let's go to let's go for this. It will give us some play for aligning the oxidizer pipe. Hit the OK button. And now let's do the same here. And hit OK. Now these two parts are connected. Okay, so we already have our combustion chamber, our nozzle, pre-burner, turbo pumps, and the gimbal mount. Next step is to add the actuators. So here we've got our rocket engine actuator. We need 2 of these. So again, let's copy and paste it. Ctrl C, Ctrl V. Okay. And this time we will go for a ball joint. So let's go for motion, ball, position. Select our ball joint that we have here. Of course, in this model it was really roughly sketched. So in real life, if you would create a ball joint like this, it would just pop out. So in reality, most of the time it will be a complex part that consists out of, in this case it only consists out of 2 components, like the socket and the ball, but in real life most of the times it will consist out of multiple parts, so that your ball joint that can get loose or don't fall out. But for this it was just for a model for our poster, so it sufficed. Hit OK. do it for the other side as well. And you can also just change your joint type here. Don't always have to go to motion. Hit OK. Now we will go for our what are they called again? Our flex joints. Okay. This time make them rigid. Position. Same for the other side. It also helps to look at your local reference system. As you can see here, the z-axis is along the axis of the cylinder, and then here you can see your x and y axis. Sometimes it really helps aligning your parts. Like even in some cases, it's necessary to align these. As you can see, like the z-axis is aligned, and now just flip it, and it's in position. Now we will take the actuator rod. And now we will, let's see. Let's first add the slider. We'll just choose a cylindrical joint, as this will enable it to rotate as well. Let's just choose the middle of it. And choose the middle of this. And as you can see now, it can slide in and out and at the same time rotate. Do the same for the other piston arm or our actuator rod. Here. Hit OK. And the next step is to connect these using a ball joint. What we'll do is we'll select the inner ball joint or our socket and select this ball. And yes, this is like pretty normal that this will happen, but you can fix it just by sometimes changing the order in which you connect the parts. Like sometimes it will fix it if you just first select this one and then select your actuator rod. Hit OK. In this case it doesn't, but let's just try to bring it to a neutral position. Yeah, sometimes you really have to watch out, so it can do some pretty weird stuff. But again, the more you'll work with it, the more you will get used to its quirks that it has. Depending on which software you use, like I haven't figured it out in Fusion yet, but I know like in Autodesk Inventor, which is also a product of Autodesk, it knows when an object is solid. So if you create a joint, it won't intersect with it, like because it knows this is a solid, they cannot intersect. Which in this case, as you have seen, sometimes it just intersects. Yeah, there's like no clash collision detection, or maybe I've just haven't found it yet. Okay, let's hope that this time it works. Yes, okay, now it's working. Let's try to bring it in a position like this. Okay, now do the same this side. But as you can see, this is already quite a good demonstration of how you can simulate the degrees of motion your design has. So now it's almost in a neutral position. But I think this illustrates how you can create joints, different joints that there are, and what things you have to look out for. So I hope this video was interesting and that you've learned a lot. Also, maybe a quick note before ending this video is if you, especially if you create larger parts, it will become very messy really soon. This due to all the joints that you can see. You can just hide them by going to your joints tab and just hitting the eye icon, and then all the joint symbols will disappear. And then to make them appear again, just hit the eye icon again, and here they are. So as you can see, the different colors indicate different kinds of joints, different degrees of freedom. So this was a tutorial on how to create a basic assembly. And in this case, if you just save it, user save. Let's now go back to our courses. Then you will see a preview here, if it's loading at least. So let's save it again. So normally we'll see a preview just as it generates the same preview with the other parts. So yeah, every time you change something, you add a part, you can see it. Okay, I hope it was interesting. I hope you learned a lot. I'm looking forward to the next video, and especially meeting you all during the online event of the design contest for Fusion 360. Have a good evening, have a good day. Goodbye. Thanks for watching.